Okay, well, let's go ahead and get started. It's 12:02, and I appreciate everybody who has joined us for the May edition of the Northwest Gas Association's monthly webinar series. We're excited to welcome Gina DeFrancesco from the American Gas Association to our webinar presenting on the EPA inventory of greenhouse gas emissions and sinks. I really appreciate the work that Gina does in this regard. She helps me understand the implications of the EPA's inventory with regard to the natural gas system. She does great work kind of digging into the EPA inventory and really breaking it apart so we can understand what that inventory is saying about emissions from the natural gas value chain. And Gina's been doing this for a couple or 3 years anyway, and she's very good at explaining this stuff. So I hope you all find this information useful. I use it every day if not every day, pretty close to that in my advocacy work, because I find that there is a lot of misconception about the emissions from the natural gas system, particularly methane emissions upstream. And some of that is, as you all know, I think, purposefully being distributed, but in a lot of cases with policymakers, they just don't know except what somebody has told them, and sometimes they haven't always been told the most accurate information. So this is super useful information to me, and I hope you'll find it useful as well. Before we get started, couple housekeeping items here I want to go through if I can. There we go. First is our June webinar. Will be June 17th, I believe is the date. And the Gas Technology Institute, GTI, will be joining us to tell us about hydrogen, enabling a low carbon future for the gas industry. Just some of the developments they're doing on helping some of the technology developments around hydrogen and the work that they're doing at GTI in that regard. So most of you, I'm sure, are old hands at the Northwest Gas Association's webinar series, but for those who are new, just a reminder that you'll be muted throughout the presentation. If you want to ask questions, please use the chat function at the top of the screen or bottom of the screen, depending on where it shows up on your screen. Use that chat function to post your questions, and I'll be paying attention. I'll interrupt Gina at an opportune moment, hopefully when she takes a breath and not mid-word, to ask her questions as they come in. So if I don't get on it right at the second you submit it, it's because I'm waiting for a natural break. But I will get to those questions as best we can. We are recording this webinar, and it'll be posted to our YouTube channel later this afternoon. And Gina's generously said that her slide deck will be available. You can contact me directly or Gina. I'm happy to provide you with her contact info, subject to her permission. I guess I should have asked you that first, Gina, but pretty sure you'd say yes to that. So those are the notes for today. And Gina, I'll give you just a minute to look at her bio here. She's been there since 2019 at the AGA. She works in the Energy Markets Group and does a lot of good analytical work. And I can tell you that Gina and Richard Meyer in that group have been, as I said before, absolute stalwart allies as we've negotiated a couple of difficult bumps around emissions, particularly with the Power and Conservation Council and others. They really help bring some good information to bear. So she's got a double Bachelor of Science degree in environmental and energy engineering. And Gina, I'm going to go ahead and stop sharing my screen and allow you to share yours. And Gina, take it away.
Great. Thank you, Dan. I'm really happy for the opportunity to be here. Let's see if my Zoom skills hold up here. All right. Dan, can you see the presentation?
Yep, it's up and raring to go. Thanks, Gina.
Great. Awesome. All right. So good afternoon, everyone. Like Dan said, my name is Gina DeFrancesco. I'm the Clean Energy Analyst at the American Gas Association. I've been at AGA for a little over 2 years now, and I work in the Energy Analysis Department. Today, I'm going to be giving an update on the Environmental Protection Agency's annual inventory of greenhouse gas emissions and sinks. In this presentation, I'm going to spend some time reviewing the key natural gas system emissions, and then on the latter half, I'll focus on what AGA is doing. There we go. All right, quickly by way of background, if you're not familiar, AGA represents more than 200 local energy companies that deliver natural gas throughout the United States. Like I said, I work in the Energy Analysis Department, and as a department, we use data, statistics, and analysis to support and understand the role of natural gas in a clean energy economy. So to that end, studies about greenhouse gas emissions and methane are released every year, and they can be pretty contradictory. So every year when we start to analyze these studies, we like to start with the Environmental Protection Agency's inventory. We use this analysis kind of as our baseline when these other contradictory studies come out to compare it to that. The EPA has prepared its inventory since the early 1990s. Throughout this presentation, you'll hear me just reference it as the inventory because its whole name is quite a mouthful, so I'll try to be short with it. But this annual report, it's released every April, usually around April 15th, and it's the most comprehensive accounting of total greenhouse gas emissions for all man-made sources in the United States. So the inventory contains emissions from every sector and every fuel. If something is emitting a greenhouse gas, you can bet that the inventory is accounting for it. The inventory also calculates sinks, so the removal of carbon dioxide emissions from the atmosphere. This includes the uptake of carbon in storage, vegetation, and soils. I won't be covering those today, but I just want to mention that removal of emissions is also in this report. Go back here real quick. For reference, the EPA reports all emissions in carbon dioxide equivalents. So as I'm talking through the report today, CO2 equivalents is what all these emissions are going to be in. They calculate this by weighting different air emissions by their respective global warming potentials to account for varying levels of radiative forces for each gas relative to carbon dioxide over a 100-year time horizon. This is important to note because higher global warming potentials would increase the contribution of methane or other greenhouse gases relative to carbon dioxide. So each year in the inventory, they make some new updates. This update that was released in 2021 has all 2019 data. There's a 2-year lag from the inventory and the year it reports on. These updates are typically to data and methodology and calculation methods, and they do this just to improve inventory quality, be more transparent, completeness, consistency, and just overall usefulness of the report. As more data is released, they like to incorporate it where possible. So I'm just going to take a few minutes to talk through the updates that are new to this year's inventory. Main recalculations in this report include updating produced water methodology and updates to customer meter methodology. The produced water update didn't impact natural gas distribution systems at all, and I'm not too familiar with it, so I'm not going to touch on it, but the updates to customer meters did impact natural gas distribution systems. I want to describe that update and its significance really quickly here. The EPA, they updated commercial and industrial meters within the customer meter category. They previously used a study with emission factors from GTI in 2009 to calculate this data, but this new inventory does a weighted emissions factor over a GTI 2009 and a GTI 2019 study. And the previous inventory, the 2009 only study, was a lower emissions factor. While AGA supports efforts to improve accuracy in the data in the inventory, we did have some concerns, and we were disappointed to see that the EPA ended up going through with this update after they proposed it last September. This new weighted emissions factor, it's a national factor, it's not regional. So when they apply it to the whole nation, it doesn't account for the significant variance in equipment type and location. And ultimately, it's an inaccurate representation of commercial and industrial meters.
Gina, can you expand on that a little bit? So for instance, out here in the Northwest, we had a study done by Washington State University that indicated that distribution systems in the West, really, but in the Northwest also in particular, are significantly tighter than other distribution systems across the country. So is that what you're referring to when you indicate some concerns about this weighting that doesn't take into account regional distinctions?
Yeah, absolutely. Dan, you put it well. When you're taking emissions factors for a region that's potentially not as tight and then applying it everywhere, the overall average is going to be higher and obviously affects your region. And it's just a inaccurate representation. I think you said it best, not to be repetitive, but there's different equipments depending on the region, and all of that needs to be accounted for. So AGA submitted comments highlighting these inaccuracies and kind of said, hey, just push pause until we can collect more data and potentially use regional specific emissions factors. This was back in September, so we were a little disappointed to see this update when the report was released in April. Every year in the inventory, at the end of the natural gas section is where these planned improvements are released. So in the April 2021 release, they noted their planned updates for next year. And since it is such a massive report, it's not surprising that preparation for 2022's inventory began the day this report was released. But I will be touching on the proposed updates a little later in the presentation for next year's inventory. All right, so we can dig into the report here. Here are the key highlighted findings of the report. I'll give you a second to read through them, but I just want to highlight these very quickly. I'll get into more details on each of them later on, but putting these up front so you can get a sense of what's to come and just a vision of the story from the inventory. Some of these key findings include methane emissions from natural gas distribution systems declining 69% from 1990 to 2019, while total natural gas system emissions have declined 16% over the same time period. Additionally, industry-wide natural gas emissions as a rate of production, which you also hear called the leakage rate, is 1%. Some more key findings here of note are the primary emitters of methane and their share of the overall emissions profile. Like I said, I'll get more into detail on each of these later, but just noting that methane released from natural gas systems accounts for only 2.4% of all US greenhouse gas emissions.
And so, Gina, will you be talking about kind of making the comparison given the updates that they used? So what's that look like for last year? 2%, 2.4%. What was it last year? 0.08 for distribution systems. What was it last year? So we'd be covering that.
Yeah, I can get into that. I think last year methane from natural gas systems was 2.7%. So even with the increased distribution numbers this year, methane's share from natural gas as opposed to the overall US greenhouse gas emissions, it did decrease. And I will get into the decreased leakage rate a little bit later. The customer meter methodology with the new data, it resulted in a 165% increase. It's definitely a noteworthy change, but that's what contributed to the increase in distribution system emissions. All right, so let's take this to the highest level of the inventory. I'm going to kind of start real high and then eventually get down to natural gas distribution systems. So if we take it to the highest level, this is where we are at today. US greenhouse gas emissions are down 12% since 2005. I'm going to focus on carbon dioxide and then more on methane, but I want to note that other gases are tracked within the inventory. If you see that light green bar, that's where we find the hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, and nitrogen trifluoride. I'm not going to touch on those today because going through every detail of the inventory would need much more than an hour, but I do want to note that their decline has contributed to the overall decrease in emissions as well. But we can look at this chart here and see the decreasing trend. And the first thought is, okay, well, how did natural gas play a key role in this decline? Well, in 2019, United States greenhouse gas emissions totaled about 6,500 million metric tons of carbon dioxide equivalent. That was that 2019 bar we saw on the last slide, down 12% from 2005. Of that, carbon dioxide from fossil fuel combustion accounts for the majority, about 74%, which is equal to about 4,800 million metric tons. And that number is 16% lower than 2005 levels in 2019. And of that share, petroleum combustion accounts for the largest amount of energy-related CO2, which is 45%, followed by natural gas at 34%, and then coal at 21%. And although natural gas consumption has increased relative to coal, given the lower carbon emissions per unit of energy relative to coal, overall CO2 emissions since 2005 have trended downwards due to the low carbon content of natural gas and ultimately increasing or contributing to the decrease that we saw.
So I just want to remind our listeners, Gina, that if you have any questions for Gina as she proceeds through her presentation, please use the chat function and type it in, and I'm monitoring that chat function, and we'll pose your question for you. Thanks, Gina.
Thanks, Dan. All right, so now we're going to dive into methane. It's the second largest contributor to greenhouse gases after carbon dioxide. Of all emissions, methane accounts for 10%. Some major economic sectors that produce methane emissions are agricultural processes, natural gas systems. You can see the whole long list here, but in agricultural systems, that's what we can see: enteric fermentation, rice cultivation, composting, all those different segments on this chart. Natural gas systems account for 23% of all methane emitted, right behind enteric fermentation at 27%. But by these categories, it's important to realize that categories matter. So when we think of agricultural systems, there's no agricultural category on this chart. Rather, it's split up into many different kinds. So the enteric fermentation, the rice cultivation, they all have their own category. Whereas if you combine them all together, that leading source of emission would be much higher than natural gas. But when we look at natural gas systems, that's every part of the system from production to distribution, all under one category. So it's hard to pinpoint how small natural gas distribution systems represent of this chart. There we go. So here's just a fun picture of the whole natural gas system, depicting all of those parts that I mentioned previously. Everything on the left side is upstream, and everything on the right side of this image is considered downstream. In 2019, natural gas utilities delivered 54% of natural gas consumed across the country. And they did this over 2.6 million miles of pipeline, compressor stations, meter and regulating facilities, and all the other related equipment. So this is just a quick picture of how much gas is going through these pipelines daily and how much natural gas systems have been able to reduce emissions even with such an extensive network. So the EPA categorizes the system into 4 stages: natural gas field production, processing, transmission and storage, and distribution. Exploration is listed on here. It's not considered a main category though, because it's such a minor part of emissions, only 0.3%. In 2019, natural gas system methane emissions equaled 157 million metric tons, or 2.4% of total US greenhouse gases. The largest share of these emissions come from production, followed by transmission and storage, and then processing and distribution each represent about 9% and 8%.
Gina, I do have a question for you. What conversion factor does EPA use to convert methane to CO2 equivalent? I know there have been debates about the time frame to use in determining the conversion, which can result in different factors. So I think this is the, is it 20 years, is it 100 year? What's the multiplier?
Yeah, so it's, I can't remember it off the top of my head. I know I should. I just kind of keep the conversion on a spreadsheet and then just use it when I need to. But they do use the 100-year time factor, not the 20-year.
And then another question just came in. Production onshore and offshore have similar emissions, but isn't onshore production a much larger volume?
Great. Onshore a much larger volume?
Yeah, so I think the question is, aren't we emitting more from offshore production per unit produced? I think that's the question here. If they're equivalent offshore and onshore, but there's a lot more, we're producing a lot more onshore, doesn't that imply that offshore production is not as tight?
Yeah, I'm gonna have to defer on this question again too. I know the majority of production is offshore, that is correct. The onshore production, those were where some new updates occurred this year with produced water, and I know that value is increased compared to last year. When I do this analysis, I kind of focus on the distribution systems, so I'm happy to look into that more and then get back with an answer on that question.
Thanks, Gina.
Yep. So looking at the whole natural gas system here, and the percentages. So just noting where distribution is in this piece of this pie. So counting emissions from the whole natural gas system, methane emissions have declined 16% from 1990 levels. This is down from about 187 million metric tons that you can see here in 1990. Again, just a testament to natural gas efforts to reducing emissions along the value chain. So if we break up each one of those bars in the previous slide, I want to take a minute to highlight distribution's noteworthy decline. So within the natural gas system, if we break up these emissions by share, you can see in 1990, distribution had a pretty significant share of those emissions in that navy blue at the top of the bars. And over the time period, production emissions have actually increased. However, distribution emissions were so significant that they helped offset and lead to an overall decline. So like I mentioned, the largest share of natural gas system methane emissions is from production, which accounts for 60%. However, production of natural gas is at record highs. New control technologies and better industry practices have contributed to these significant emission reductions. So even as natural gas production and consumption have hit these record highs, absolute methane emissions have still declined 16%. So here on this slide, we can see the incline of gross natural gas withdrawals, and then the emissions from natural gas still declining. Along those same lines, we can examine the methane emissions per unit of natural gas produced. So to do this, we calculate kilograms of methane emissions per unit of gross natural gas withdrawals. This calculated value gives a ratio that can be then used to compare to other fuel streams. And this ratio, it serves as a measure of the efficiency of natural gas production as it relates to methane emissions. So over the past nearly 3 decades, methane released from natural gas systems has declined as production has risen. And as this figure shows, taking the ratio of these values, methane emissions per million cubic feet of natural gas have declined 57% from 1990 to 2019. And like I mentioned a little earlier, there's a lot of question out there if the EPA's inventory is undercutting the amount of methane emissions. But this chart really shows that no matter what, there is that downward trend. And the slope of this line is always downward no matter where you look. So production of natural gas is getting more efficient over time. And again, part of this improvement is the application of better industry practices, advances in technology, and investments in lower emitting equipment and infrastructure. Okay, so moving on to natural gas distribution systems specifically, this figure summarizes the breakdown in distribution system emissions by source category. The majority of emissions occur from pipeline leaks and customer meters in the gray and navy blue here on this pie chart. Less than 41%, or less than half, about 41% of distribution methane emissions are associated with customer meters. This surpassed pipeline leaks this year in the inventory as the top distribution emission source, in part to the new update that I talked about earlier. Pipeline leaks, they used to represent almost half of distribution segment emissions, but they now represent 37%. 8% of emissions in distribution result from the operation of gas meter and regulators at city gates, which connect the transmission system with the distribution network. Upsets and routine maintenance together comprise 13%. So overall, emissions from distribution systems have been improving even as the size of the system has grown significantly. Methane emissions from distribution systems were 14 million metric tons in 2019. That's down 69% from the 1990 level of over 45 million metric tons. And this drop occurred even as the industry added approximately 788,000 miles of pipeline to serve 21 million more customers. And this figure kind of shows that awesome statistic, right? So it reproduces EPA estimates for pipeline leaks using emissions factors for pipeline mileage data. That's from the Department of Transportation. At the same time, this figure shows the increasing trend in miles of installed main and the simultaneous decrease in emissions from main pipeline. It just illustrates the nation's expanding service territory with a declining environmental footprint. And these historical reductions are the result of gas utility upgrades to distribution infrastructure, improved leak surveys, and modernized designs. Pipeline networks have been expanded and replaced with modern materials, such as protected steels and plastics. These have lower emissions than other pipe materials. Additionally, operators have made significant upgrades and rebuilds to equipment at meter and regulating facilities. So I know that was a lot of data, and we can listen to it all, but the main point that if I want you to get out of this webinar is that the inventory reveals that natural gas distribution systems, they have a small emissions footprint shaped by a declining trend. And this inventory, it's a continuous work in progress. There's constant updates every year, and trends in natural gas system emissions signify how new information better informs understanding of the greenhouse gas profile of natural gas production and use. New information will continue to refine the emissions estimates in the inventory, and it offers to industry, the public, and policymakers a better understanding where emissions occur and the levels of methane released. So better information helps focus attention on cost-effective opportunities identified in the data. So to that end, whenever new information is released, we like to analyze it and compare it to the inventory. And I kind of just want to walk through a few of those studies and what that looks like when we compare these studies to the inventory. So a study published in the July 2018 journal Science, it made some headlines at the time, particularly with the claim that US oil and gas emissions were 60% higher than estimates reported in the EPA's inventory. These studies' results were a provocative finding, and they had some corners asking whether the industry had a leak problem. At AGA, we had some questions about the study's methods. I don't want to focus on the technical elements of the study today, but I do want to focus on the study's findings. So those findings were that, in short, supply chain emissions were equivalent to 2.3% of gross US production. Then this value is 60% higher than the EPA's inventory that I just spent the past 20 minutes talking about. So obviously this rose some red flags for us. But when you dig into the study, we found that natural gas methane emissions were actually similar to the inventory when uncertainties were accounted for. So we found that by reading in, and the authors, they reported that oil and gas methane emissions represented that 2.3% of gross natural gas production. They didn't report a gas-only value, but it's likely to be around 1.7 to 1.8%. When you use the uncertainty range from the reported combined oil and gas value, natural gas system methane emissions would exhibit a lower bound estimate of about 1.5%. And this value, it's actually very close to the upper bound estimate from the inventory, which is about 1.4%. So in other words, the results from this study, they're not wildly out of sync with the inventory, even though headlines from this journal article may have made it seem like that.
And not incidentally, headlines from that article were used to, in our very region, to promote a different assessment. So,
right. It's a shame sometimes what the headlines can miscontrey, but this new study also shows that natural gas provides climate advantages over coal. Like I mentioned, the authors reported a combined oil and gas value of 2.3%, and the gas-only number would be around 1.7 to 1.8. And that's half the 4% that a research study from Yale showed would be the short-term break-even point for coal versus natural gas. But all this to say, doesn't mean we can't do more to reduce emissions. We should, and we are doing more. And we believe additional science will show that emissions are lower still and that they continue to drop. Another study that I want to walk through here, this one's from the Earth Systems Research Laboratory at NOAA, which is the National Oceanic and Atmospheric Administration. The research found that there was no increase in total methane emissions from 2006 to 2015. The data showed that there has been a modest increase in emissions relative to oil and gas operations, although it is significantly less than prior studies suggested. The study found that overall methane concentrations were relatively constant across the US, increasing only 0.01% per year. The analysis also concluded a modest increase. Like I mentioned, this was 3.4%, but this increase was 10 times lower than claims of other studies. And how they found this, they took ratios of methane to ethane and propane. So methane can be released from several sources apart from oil and gas operations. Like we saw earlier, all the agricultural processes, landfills, and coal mining. So attributing the source of methane detected can be difficult. To help identify whether the source of methane is from oil and gas operations, analysts often look to measure ethane and propane emissions. These heavier hydrocarbons, they're often co-produced with methane during oil and natural gas production, but they're not generated by biological processes. So they can be used to distinguish methane emissions from oil and gas operations. Earlier studies typically assumed this ratio of ethane to methane and propane was constant, but this NOAA study, it said that that's an improper assumption. They found much larger trends in ethane and propane compared to methane, even where methane emissions were principally contributed to by oil and gas activities alone. So they determined the large increases in propane and ethane do not suffice as evidence for large increases in methane. And this NOAA study is just one more step in the continual improvement in measurement and analytical methods. They help shed light on questions of methane emissions from oil and natural gas operations. And I just want to mention that there is a lot of science out there and it can be confusing. So, and like I mentioned, they have contradictory headlines, but all this is to say that when you dig into these studies and you look at the assumptions and the methods, that they're not so much different than they may seem. And this study is just one of many out there. So I mentioned I talk about what AGA is doing in the methane emissions realm. And as the picture of methane emissions is continually evolving, as an association, it's important to note the role we are taking. So AGA and its members are committed to supporting studies to collect accurate measurements of emissions from natural gas utility operations. Further ongoing data collection and analysis from the government, academia, and industry helps inform better public understanding on natural gas methane emissions and the role natural gas systems play in reducing overall emissions. One of the studies we supported is the Basin Methane Reconciliation Study. It was designed to understand the persistent gap between top-down and bottom-up methane emission estimates for production regions. It was designed as a first of its kind. It did measurements at the device, facility, and regional scales with site access and activity and emissions data input from local natural gas operators. If you're interested or if you haven't seen the study, you can find the paper, a slide deck, and a really good short summary video at the website at the bottom of this slide. And like I said, these can be shared after the presentation if you are interested. Some other things AGA is doing is engaging with EPA on their natural gas STAR and natural gas methane challenge programs. Last year, AGA developed transparent, investor-driven, industry-specific environmental, social, and governance metrics for natural gas utility operations. When these were being created, we went to key investors, rating agencies, and analysts, and we asked them what would be important to include. And they said, first of all, just keep it short and keep it easy to use. But for gas utilities, they said, focus on methane and safety. So AGA worked with member subject matter experts to develop quantitative and qualitative metrics, and then vetted them with this investor group. Version 2 of the ESG reporting template was released in August 2019. In 2020, 25 member companies posted their ESG metrics using the ESG template. And I believe 2 days ago, on Tuesday, version 3 was posted. For the second bullet here, the Natural Gas Sustainability Initiative, this goal was to measure, report, and recognize progress in advancing sustainability across the supply chain. NGSI was to be broader than ESG metrics in its scope and audience. So where ESG focused on what investors want to know about gas and electric utilities, NGSI also looked at what regulators and customers wanted to know about the sustainability of the product, and it was across the entire supply chain. In 2020, 12 companies participated in the summer methane intensity protocol pilot. This included 7 AGA members and 5 upstream companies. This NGSI initiative, it will be a living document that will evolve based on experience and what is needed to demonstrate natural gas sustainability. It's going to be an iterative process for sure, but the staff member who I would like to recognize for these efforts is our Chief Regulatory Counsel, Pam Lacey. With that said, she is the expert on these and she created them. So if you have any questions about ESG or the Natural Gas Sustainability Initiative, I'm happy to connect you with her because she will know a lot more about these than me. Finally, AGA is continually tracking and providing comments on proposed updates to the inventory. Like I mentioned earlier, these updates come every year and they're proposed starting now, and they go into September with memos and stakeholder review periods. So I just want to talk through the updates that we might see in 2022's inventory. So EPA is proposing updates to post-meter emissions. They're considering including estimates for emissions from appliances in commercial and residential sectors. This would include leakage from house piping, appliances, home water heating stoves, and barbecues. The inventory currently does not include these, but the IPCC report has recently updated to include them, so they would like to be consistent with that report. AGA has some concerns with the update, mainly because right now, there's no standard approach for measuring these emissions. So the studies that EPA is considering taking the emissions factors for the appliances from, they're not comparing apples to apples. So it's kind of the same deal with the commercial and industrial meter update, where we need more data. We need a standard approach before we can include these in the inventory. But to that end, any comments AGA provides will always follow science and provide objective information in our comments.
So Gina, I have a question on that. You
Yeah.
indicated that what they're looking at would maybe rely on not apples to apples kinds of studies. Are they proposing an emissions factor for these purposes based on I don't want to get into the weeds, but based on something that's out there or a variety of studies, and just trying to do a spitball sort of kind of where it's at, number one. And number two, do we have a sense? I have been speaking with a climate a scientist out here who you're familiar with. He's indicated that, you know, it's possible that that if this stuff were out there, that they might find as much as a doubling of the contribution of distribution systems to the overall emissions rate for the natural gas value system. But if distribution systems are at 0.08 now, doubling it would make it 0.16, which would it even bring it up to 1.1% overall for the gas system? I mean, I know that's not a good picture for distribution systems, but is it a material impact? It is for our system.
Right.
But is it a material impact for the overall picture?
Yeah, so to address your first comment, where we're at with these proposed updates is all the EPA has listed. All we know is a few studies that they're considering. They listed them out and they asked for stakeholder feedback on those comments, like which of these would be the best to use. So I don't know of any studies for emissions factors that they're set on using for this. The update process for the inventory, what happens next is usually in September, the EPA will release memos on these proposed updates. And that's kind of where we'll get a little more information. AGA is trying to get in with EPA before they put pen to paper and before they even get to that point to say, slow down. These studies, they're not all standard. We need a new solution before we can include them. To your second point, yes, it could have a significant contribution to distribution emissions. But like you said, right now, the 0.08% of distribution emissions of produced natural gas, I stole this analogy from my colleague, but right now that's like a little tiny gnat. It's so small, but if we double that, it's a tiny little fruit fly. So it's still such a small amount, but I mean, you don't want to see the inventory incorporate any data that is inaccurate representation. So updates to come, but we shall see.
Thank you. Yeah.
But on that note, that is a quick update of the inventory natural gas system emissions, what AGA is doing, and I'm happy to take any questions. And this link on the bottom of this slide here, this is where you can see my written report and a lot of these slides used today. You can see those figures there. But I'm happy to answer any questions, but thank you.
That's great, Gina. And you have your phone number up there so people can call you directly if they have questions. I'm going to forward you an email from the person who posed the question about offshore onshore, so you get a better sense of what he's
perfect.
What he's getting after, and I think it's pretty clear. So any questions, any other questions for Gina, please use the chat function. I'm going to try to stall a little bit. I won't dance, but I'll verbally dance maybe while I give you a moment to ask any additional questions you might have for Gina. Just a reminder that our next webinar on June 17th will be from the Gas Technology Institute, GTI's work on hydrogen and helping develop that low carbon pathway for the gas industry. Should be really interesting. They're doing a lot of great work there, and to help drive these numbers even lower. They're pretty low already, I'd say. And then I'll just add one more pitch for Gina and the crew at the American Gas Association. As you can tell from Gina's presentation, they are a terrific resource for data and analysis. I use them all the time, unashamedly plagiarize their materials whenever possible, with their permission, by the way. And they're just really great. And so let me know, if you need me to plug you into somebody there, I'm happy to do that. Well, with that, Gina, I don't see any additional takers on the chat. So we will thank you one more time for your time. I'm getting lots of good feedback. Thanks for the great information, great presentation. And I concur with all of those comments. We appreciate your time, Gina. And to everybody else, we look forward to seeing you in June. Remember, if you want those slides, I can provide them to you. So just ping me and I'll get you that deck. If you, June 17th for our next webinar. And we look forward to hopefully seeing you all in person sometime sooner rather than later. Thanks, Gina. Thanks, everybody.
Thanks, Dan. Thanks, everyone. Take care.